Hi, this is Margo. This is Sunday early evening, June the 26th, 2022. I would like to welcome everyone to the show today. This will be my weekly update that I'll be putting on YouTube. We're going to go over methane, climate-related items, sea ice, some earthquakes, and I've got a couple of articles, though, that I want to start off with. One is having to do with the fires in Siberia, and this is from the Moscow Times. This is from May 15th, and it says summer wildfires ravage forest-rich Siberia in photos. And so this is early in the season that a lot of Siberia is already on fire, and this is a real problem. It's hard for them to put them out, and they just don't have the right enough people and equipment and stuff. And also, these fires are fueled by peat. And a lot of them were coming up through the permafrost, and so you just can't get them put out. So it says large swaths of Siberia are in flames as what looks to be another record-breaking wildfire season sets in. Environmental group Greenpeace said last month that this year's wildfires are already twice as large as those of the same time last year. Acting Emergencies Minister Alexander Chupryan said this week that Russia has seen over 4,000 forest fires across 270,000 hectares, an area larger than Luxembourg so far this year. Now remember, this was almost a month and a half ago. Climate experts have sounded the alarm over the increasingly intense annual wildfires, saying the burning trees release massive amounts of carbon while melting, well, they should have said thawing, but they said melting methane reach permafrost. They also threaten human lives, with 16 people having died as a result of the fires in the past week alone. The wildfires have become increasingly destructive in recent years as Russia's northern regions warm faster than the rest of the world. The 2021 wildfire season was Russia's largest ever. President Vladimir Putin told Chupryan that we cannot allow a repeat of last year's situation when forest fires were the most long-lasting and intensive of recent years. And here are the pictures where we can have a closer look. This is in a town. Here's damage from a wildfire that spread to urban areas in the town of Uyar in Russia's Krasnoyarsk region. Look at this. Here's a state of emergency has been declared in Krasnoyarsk region over the wildfires. It just levels everything. A wildfire covering an area of 20 hectares rages near the Yakor or Angkor Dacha community in the Tyumen region. That looks more rural. Look at this. It's just a wall of fire. Local firefighting forces are typically made up of civilian volunteers and have faced dividing resources in recent years. And apparently they have fewer resources since with the Ukraine war going on. Firefighters at the scene of a fire in the Omsk region town of Nozhgulyevsk in southern Siberia. The fire damaged 29 residential houses and 23 non-residential buildings. Some 165 people, 23 pieces of equipment, and a firefighting train were involved in the firefighting effort. The Omsk region has declared a state of emergency over the fires. Look at that. The infrastructure looks like it was heavily damaged there. Look at the poles that have fallen down. Look at this road. A road's wrapped in smoke from a wildfire on the border of the Kazansky district and Nadensky district of the Primory region in the Russian Far East. And you can see the roads buckling there from the heat. Western analysts have said that Russia may have sent much of its military aircraft used for tracking wildfires to Ukraine, where Moscow is waging a military campaign. And there's that. Look at this. A dog is seen in the Malinovka Docha region in the Kurgan region following the wildfire. Wildfire in the Kurgan region. There's that fire truck. Here's some firefighters. Russia plans to use its vast forests as part of a carbon capture program, allowing it to reduce its carbon emissions to meet global climate goals while still increasing its fossil fuel production. Critics say Russia's climate strategy is not ambitious enough as it uses its emissions following the Soviet collapse, when industrial activity slowed to a halt as a baseline. Look at that. So that's that article and all of those pictures. And then the second article, this is from Sam Carana's Arctic News, arctic-news.blogspot.com. This is his latest posting. It's dated June 20th, but he keeps updating it for a few weeks afterwards. And it's titled Arctic Sea Ice June 2022, Why the Situation is So Dangerous. And so here's the first chart. On June 22nd, which was the day after the solstice this week, Arctic sea ice extent was among the lowest on record for the time of year. And we can see the line there right towards the bottom. This is from Zach LeBay, and the image below shows Arctic sea ice extent up to June 20th, 2022 based on fish-out data. The yellow line is the year 2022. The white line shows extent for the year 2012. when it reached a record minimum in September. The blue line shows extent for the year 2020, when the minimum in September was second lowest. So we're right there with the lowest things there. Here, the image below, adapted from VisShop, shows that on June 23, 2022, global sea ice extent was at a record low for this time of year. See, down there. The fact that sea ice is so low for the time of the year is the more striking as we are currently in the depths of a persistent La Niña, which suppresses the temperature rise. El Niños typically occur every 3 to 5 years, according to NOAA, and is also illustrated by the NOAA image below. So the upcoming El Niño can be expected to occur soon. The NOAA image below indicates that going from the bottom of a La Niña to the peak of an El Niño could make a difference of more than half a degree Celsius or 0.9 Fahrenheit. So almost a degree in Fahrenheit. Furthermore, the rise in sunspots from May 2022 to July 2025 can make a difference of some 0.15 degrees Celsius or 0.27 Fahrenheit. The next El Niño looks set to line up with a high peak in sunspots in a cataclysmic alignment that could push up the temperature enough to cause dramatic sea ice loss in the Arctic, resulting in runaway temperature rise by 2026. The National Snow and Ice Data Center compilation below illustrates how much multi-year sea ice has already declined over the years. The top panel shows the age of Arctic sea ice for the March 12th to the 18th period in 1985 and 1922. Here's 1985. Here's 1922. Let's see how much it's gone down. The oldest ice greater than 4 years old is in red. In plot C, and shows the time series from 1985 through 2022, a percent cover of the Arctic Ocean domain by different sea ice ages during the March 12th to 18th period. There's that chart. And so here it was 2021, where it was just a very little bit that was over, just over 4 years old. And most of it's 1 year old or less. See. Arctic sea ice volume. On June the 18th, the Arctic sea ice volume was among the lowest on record for this time of year, as illustrated by the image below, adapted from Polar Portal. And here we are, right with those other lines. The blue ocean event occurs when virtually all sea ice disappears and the surface color changes from white for sea ice to blue, which is ocean. According to many, a blue ocean event starts once Arctic sea ice extent falls below 1 million square kilometers. The image on the right shows a trend pointing at zero Arctic sea ice volume by September 2027. Note that the volume data in the image are averages for the month September. The minimum for each year is even lower. Furthermore, since zero volume implies zero extent, this indicates that a blue ocean event, or the extent below 1 million square kilometers, could happen well before 2027. So it doesn't have to be total no sea ice. It's below 1 square million kilometers. So there's that. And then there's the Navy model, which I include in my reports. And he says the above animation shows a dramatic fall in sea ice thickness over a large area, while sea ice is disappearing altogether in some places. The fall in thickness is mostly due to warm water from the Atlantic Ocean that is melting the sea ice hanging underneath the surface. This is where the sea ice constitutes the latent heat buffer, consuming incoming heat in the process of melting. And this is out of Denmark. The University of Bremen image below shows sea ice thickness on June 23rd. And a large area near the North Pole that is less than 20 centimeters thick. See the green there. And here's from NASA Worldview, showing holes in the sea ice not too far from the North Pole. And here's the Bering Strait and the warm water coming in from the Pacific and melting the sea ice there. And this is from I'm having a brain fart. Earth Null School, where sea surface temperature anomaly in the Bering Strait was as high as 15.5 C or 27.9 Fahrenheit. At the green circle. Right here is the green circle. That was on June 10th. It was on the coastline of Alaska. Here on June 10th, the sea surface temperature anomaly. Oh, we just saw that. The NOAA image below illustrates how the Gulf Stream is pushing warm water toward the Arctic, with sea surface temperature in the North Atlantic reaching as high as 32.1 C or 89.78 degrees Fahrenheit on June 19th. And it's showing that we've lost the heat buffer with the sea ice getting so thin now. And so as the warm air comes in, it's melting the ice rather than it being buffered with the thicker sea ice. So that's his article. In conclusion, temperatures could rise strongly in the Arctic soon due to sea ice loss in combination with an upcoming El Niño and a peak in sunspots with the potential to drive humans extinct as early as 2025, while temperatures would continue to skyrocket in 2026, making it in many respects rather futile to speculate about what will happen beyond 2026. At the same time, the right thing to do now is to help avoid the worst things from happening through comprehensive and effective action as described in the climate plan. But really no one's implementing that. And there's the article. And I'll leave a link below to those two articles. And now we'll move into my report. And starting out with Climate Reanalyzer, this is 2-meter temperature for today. Here's the Arctic. We can see green, some shade of green, all across the Arctic, and that's above freezing. And see the dark green here on the edge of where the sea ice is, and that's about 5°C on the temperature. And then we've got a little bit lighter than that green here in the Bering Strait, but you can see where the warmer temperatures are coming in. Here's the flat view of the Earth. And let's see, here's the color scale down here. And the white is above 40°C, which is above 100 degrees Fahrenheit, so really hot. And we've got here in Texas and part of the southern states. Now this had been white all the way across all these southern states this week, up into South Carolina, and also white in the southwest here. Here we've got Africa, Saudi Arabia, and coming all the way up into Kazakhstan and across into India and parts of China. Here's 2-meter temperature anomaly. We see these browns all the way across the Arctic Ocean here, and brown across Alaska and down the west coast of Canada and the US. Heavy browns over this Scandinavian region and Russia. And now we've got blues along the coast of Siberia here, but browns next to that. This had been brown and red this week. And then we've got browns from Texas up the east coast up into Canada. And here's the flat view. We still have some hints of reds and browns over the Antarctic. And see the blues right next to the browns. This is where the cold air from the Arctic is escaping because the jet stream is so wavy. It's not holding that cold air in. Worldwide, we're up 0.2°C higher than normal. The northern hemisphere is up 0.7°C. Right now, the Arctic is in balance. The Antarctic is at 2.9°C lower than normal. The southern hemisphere is minus 0.3°C. The tropics are up 0.3°C warmer than normal. Here's what used to be the jet stream, and we can see a vortex here over this East Siberian Sea with a low pressure system, and then see the waviness, big wavy things on the jet stream where the cold air is escaping. And then in the southern hemisphere we have parallel streams. And this is all causing weather chaos. And here's sea ice and snow cover for today. Now I do have this in the slideshow for the last 7 days too, but we can see holes opening up in the sea ice, especially in this Laptev Sea. There's a hole opening here in this East Siberian Sea. We can see the Bering Strait is open. The extent is in high melt here in the Baffin Bay. This Hudson Bay is thinning down. The extent around Greenland, and this east side is in high melt. And we're seeing a lot of open water in the Kara Sea as well. Here's sea surface temperature anomaly. This is as of yesterday, and where the ice has melted in the Arctic, we're already seeing the water's heating up very fast, and it's already in these temperatures higher than normal. Here in the Laptev Sea, we're seeing brown, dark brown, and moving into red, so about 4°C higher than normal. And here in the Kara Sea and the Barents Sea, all along this Russia coastline, the browns and reds. And here in the Baltic Sea, that's moving into the reds. The North Sea is in the browns, and sees brown around Iceland and Greenland. Here moving into the Hudson Bay in the browns, and off this east coast of Canada and the US. And we can see the Gulf of Mexico is turning brown there. Here's the flat view, and we can see the Mediterranean, especially on the west side, moving into reds. Lots of reds and browns here. And then here on the West Pacific and around Kamchatka, look at the reds and pinks. And light pink is 6°C higher than normal. And in the Sea of Okhotsk, very hot. And then between Japan and Russia there. And then lots of browns in the rest of the Pacific and around Australia and so on. Worldwide, we're up 0.4°C higher than normal, along with the North Atlantic. Northern Hemisphere and North Pacific are up 0.6°C. The Southern Hemisphere is up 0.2°C. And the equatorial Pacific is down 0.2°C. So there's that. Now we'll move on into the methane part of the show. And here we're going to look at methane for yesterday for NOAA. This is for the 25th in the morning. The Met-Op-B or Met-Op-1 satellite. And I'm tracking this 469 millibar reading. The mean or average was 1925 parts per billion. The high reading was 2355, and we can see this pink range is coming further south all the way to the Antarctic, and this range is between 2000 and whatever the high number is in the range, parts per billion. And in the afternoon, the mean jumped up to 1927, and the high reading was 2344. Here's the spreadsheet and chart. So for the 25th, it averaged out to be 1926 parts per billion. That gives us an increase this week of 1.5. And here we can see the line going up. And we're 16.5 parts per billion higher than a year ago. We're 56.5 parts per billion higher than when I started this tracking in March the 1st. And we're in the heating season now for methane. So we should see methane pretty much going up through October now. Usually it peaks out sometime in October and then goes down for a few months. But the problem is that it never goes back down as far as it was from the winter before, and then every summer it goes up higher than the year before. And you know, how can it not, with it going up all the time? And we're 16.5 higher than a year ago. So let's see what happened this week. Here's where we were in our show last week. We were at 1924.5, and there was no change for that week. That was on Saturday. Sunday, it went up half a part per billion. Monday, it went down 0.5. Tuesday, it went down 0.5. Wednesday, it went down 1. Thursday, started going back up 1. Friday, up 1. Saturday, up 1. So we got 3 days in a row now of going up 1 part per billion, giving us an overall increase this week of 1.5 and 16.5 parts per billion higher than a year ago. So there's that. Now we'll move on to CAMS. This is Copernicus Atmosphere Monitoring Services. I have Saturday the 25th pulled up, Arctic view and surface level. Here's our color ledger. And the data is for Saturday, and the forecast period is Sunday through Wednesday. So this whole Scandinavian area into Russia is pretty much constant blob every day. And here's this hot spot off the coast of Norway, and it's still streaming up through from the North Sea up into the North Atlantic. And here in the interior of Russia, we're seeing these hot spots. See the blobby areas as that's heating up. And some of this is from fires. I didn't look up each one of those regions that I showed in the article, but we can assume that some of this is from fires. And in the North Kara Sea and around Komsomolets, it's starting to percolate again. And here on the coast of Alaska, Koktovik, in the interior of Alaska. And also, you want to watch the different shades of green that are moving across the Arctic. This is methane coming up through the sea ice. And then Canada, here below the Hudson Bay, it's a very heavy area. Here's the tar sands in Canada. And we'll go to the North Pole view. Here we can see the northern hemisphere. See, the main background color is some shade of green for most of the northern hemisphere. Here's the Persian Gulf. Here's India, China. See it streaming out there. Here's Japan. And then here in the US, look at these blob areas. It's pretty consistent where the blobby areas are. Or if it's really hot or they've had rain, then it'll turn more into the darker colors. But consistently we see high readings down through the Mississippi River on either side of that, down into Texas, also in the upper Midwest, and then this northeastern seaboard. Also Florida has very high methane because of the humidity. It's very swampy and high dense population down there. Here's West Texas. Here's California. Now we'll pop down to the Antarctic. This was interesting this week. What we saw, now down here, the overall background color is this 1840 parts per billion, but we're also seeing methane, see, coming up over the interior. That's independent. It did not stream down from South America. It's coming up independent in the interior here. See this? See the lighter color? It's very subtle, but it's at least a 1860 or 1880 reading, and it's still coming up around the Brunt ice shelf. So it's streaming out there, and here around these Larsen ice shelves on this western peninsula. Also on this south end, next to the Ross Sea, here at the Amory ice shelf, and here on the north end. So it's totally dark down there, and methane's just streaming up. Okay, now we'll go to the global view. Here you can see it around the coming up, see, over the Antarctic, where it's spread out there. Here's New Zealand. It's very high on both islands. Here's Australia. You can see it's increasing. There's that. Now we'll go to 500 HPA. And look how the really concentrated is really spread out. It's over China and Southern Asia and India here, also coming down in the Pacific there, and here in Russia, over Russia, here over the Arctic. Here's Novaya Zemlya, so it's in that region there. Here next to Greenland, also here over Australia, and we're seeing higher readings now creeping further south, even yellows over the Antarctic and reds further south as it's redistributing. And then total column. And we have mainly over India and some patches here, China, and then look at all these reds all across to Africa, here South America, and look over this whole Gulf Coast area and the southern part of the U.S. Then I want to just go over the rest of these pictures. This is sulfur dioxide today for the globe, and we've been seeing some high sulfur dioxide releases here next to Kamchatka. This is 3 days in a row. We did have some high releases north of New Zealand a couple of days ago, and this is 500 HPA where it shoots up into the atmosphere. Here we can see it next to Kamchatka. This is the Pacific view, so here's North America, South America, and then here's the Pacific Ocean. So here's Kamchatka, and here's the Aleutian Islands. And we see a high reading, and we're seeing the exclamation point form, which is indicative of sulfur dioxide being released before an earthquake. That's what I've noticed as I've been studying all of this. But the highest release is up here. Reading is up here in the Aleutian Islands. And all of these Aleutian Islands are volcanic islands, and they're prone to earthquakes a lot, and also activity. And here we still have some high reading just east of New Zealand that's left over. Now if we zoom in, that's pretty well shaped, well defined, and it's not a real blob. It's kind of a exclamation point, kind of an upside down one. So this could be earthquake related. Now over here on Kamchatka, that's probably volcano related. So we'll have to see. And here, this is from Popocatépetl volcano. Here is ozone over the Antarctic today. This is the hole that's forming. And of course this is where we saw methane coming up, where the ozone is very thin over the Antarctic. Here's the Arctic view of ozone. We can see it's starting to thin further north. It's moving into the greenish zone here in northwest Russia and Finland. Also on this right hand side, coming up into Kazakhstan. Also on the left hand side, coming across the US. Here's the global view. And we can see it's thinnest around this the equatorial regions, in all these shades of green. And then the aqua is the next color. And then I took a couple of earthquake pictures. 246 today. And we had an Arctic earthquake right up here next to Svalbard. In the Fram Strait, right on the red line. 4.3 in the Greenland Sea. This came in last night at 8:20 p.m. Pacific time. That's all of those. Now we'll move into the sea ice portion of my report. Okay, we're going to start out with this slideshow. These are images from Climate Reanalyzer, Sea Ice and Snow Cover. I save these every day. And so here we are today, and we'll just zoom in so you can get a good look. You can see where the ice is melting, where it's not solid white. and here around the edges of Greenland, that's going away. This whole eastern edge is diminishing. We've got not solid white, but it's not completely open here in the Kara Sea yet, but a lot of open water. Here in the Laptev Sea, we have a lot of open water from the Siberian coastline up across next to the Siberian Island, New Siberian Islands, also open here by the Taimyr Peninsula. And then where it's kind of grayish, it's not very concentrated at all. You'll see where it's all broken up on NASA Worldview. Here's the Bering Strait where it's open, and here's a little bit darker color where it's starting to thin out across this sea ice. Also above the North Pole here, this is where we saw the green, the hole. So that's today. So let's see what happened this week. Here it was last Sunday in my show on the 19th. Now you're not going to see a lot of difference this week, but it's going into high melt, so we'll be seeing more of a difference from day to day. So here we were last Sunday. Here was Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Like I said, not a lot of change from day to day here, because it's mainly melting in the interior, starting to thin out. Okay, next we'll go to the Navy models. This is the Arctic sea ice thickness, and the latest data they had posted is the 24th, which was Friday, so they're a couple of days behind. And here's our color ledger on the right. The thickest ice is at 5 meters thick. Not very much of that. Not very much red or yellow or even green. And the thickest ice is just above Canada and Greenland here. It's not at the North Pole, which is kind of confusing. You think the North Pole is the coldest area and the thickest ice, and it's really not. It's right here above Canada and Greenland. So here we are today, and looking here in quadrant 2, we can see the ice edge thinning down. Svalbard is open. A lot of Franz Josef Land is open, and you can see the color here going from aqua, now going into the purples and blues as it's thinning down. And here in the Kara Sea, a lot of open water around the Russia coastline. Here's the Yamal Peninsula. The Gulf of Ob is melting out. Still have a little bit of ice on this top side, or that would be the east side of Novaya Zemlya. And thin ice up here in the North Kara Sea. Open water here by Svalbard. And then coming into quadrant 1, a lot of melting and opening up here in the Laptev Sea. And you see this area where it's kind of in a semicircle that's melting out kind of faster than the rest of it. moving down into the purples and dark blue. That's about 1 meter thick there. The dark aqua is about 1.25 meters thick, and and then here, this area from Siberia all the way across into the Beaufort Sea, that's thinning down into darker aquas here. And these tributaries are starting to melt out. We're starting to see some open water, and the aqua going down into the purples, and also into just open areas as well. Here in the Baffin Bay, we can see it's just sparse ice up in this north part. And here in the Hudson Bay, that's melting out. It's almost gone. And here's the 30-day animation. Now this was updated to the 23rd, and so the data goes back 3 weeks from then, and then the forecast period goes out to the 30th, which is Thursday. So let's take a peek at what they're expecting here. So let's watch this top portion. Look how this just thins down. The rate of melt in 30 days is just astonishing. It goes from dark aqua at the beginning to into the lavender area at the end. Lavender color. And a lot of areas just opening up. And watch this area. See, it goes into dark aqua and also moving into dark blue and purple in this East Siberian Sea. And you can see that that's really going to start opening up this next week. And the whole Arctic area is in high melt now. And here in the Chukchi Sea, we can see it thinning down. And in the Beaufort Sea, we're going to start seeing more open water here, and lots of area between the pieces of ice. And so the more open water you have, even if it's just a thin line, that heats up more and will make the ice surrounding it melt that much faster. And then down here along Canada and Greenland, we can see this thicker ice. See, it's flowing out in these tributaries, and it's coming apart. Now look at this Baffin Bay, that's clearing out. Here's the Hudson Bay, and that little entryway, that's cleared out. And the extent, we can see that being whittled down along Greenland. It's high melt, like I said. Oh, you know what? I think I forgot think I forgot on Climate Reanalyzer to show precipitation. I don't know how I missed that. And it's really important to see this, so let's just backtrack for a second here. The green is rain, the snow is blue, and then we've got clouds. But look at the rain around the southern tip of Greenland. It's also coming up in the Baffin Bay and here in the Fram Strait and up from Iceland. Also next to Russia here, and here over Siberia. It's also raining and snowing over this East Siberian Sea today, and a little bit of rain over the Beaufort Sea, and then rain up here in this northern part of Russia. So it'll definitely melt that ice out fast with rain like that. And then where it's rained over that Arctic regions on land where there's permafrost, and there's a lot of permafrost up here, that'll be thawing out and more methane coming up and carbon dioxide. And here's the flat view of that. So let's go back. So this will put things into context as we watch things kind of melt out, and so it's raining over this area today. And here's the Beaufort Sea ice thickness again on the 24th, and here's the thickest ice right along this Canadian archipelago coastline, and up to 5 meters. So just a thin line of 5-meter ice. And then the yellow, going down to yellow, that's about 3.75. The green, the dark green, is under 3 meters. The lighter green is about 3 meters thick. And here's the 30-day animation, and this was updated to the 24th. So the forecast goes out to next Friday, the 1st. I can't believe we're halfway done with this year. Almost. I just can't believe it. And it's been such a hard year for a lot of people. I've had a hard year, but I'm starting to feel better, starting to heal up a little bit. And look at this thinning down in the Beaufort Sea. A lot of thin down in this week that's coming up. Let's see. So it looks like it's going to open up right down through here, and we'll have some thicker ice left next to the Alaska coastline there. And you can see it flowing out here and then being squeezed down into these tributaries. Here's that. And here's the Antarctic. Again, updated to the 24th. And the extent, the regrowth is really low. And it's not keeping up with the rate of regrowth last year. on the extent. We're seeing a little thickening from purple into dark blue here in the Ross Sea. A little bit of thicker ice around this coastline going into the aqua zone. That's about 3 meters thick. A little bit thicker ice around this west coastline. And here, this western peninsula. So this is the area where we saw methane coming up, also around the Brunt Ice Shelf, and a lot of these coastline areas, and over this interior, mainly on the northern part. Here's the Weddell Sea. We've got a little more extent coming out here, also down here in the Ross Sea and on the east side. The majority of the thicker ice is here in the Weddell Sea. And here's the 30-day animation. This was updated to the 23rd. So the forecast goes out to next Thursday. Oh, too close in. Let's go back out a little. So we can see the regrowth coming up to that line there. So there's that. Now this is from National Snow and Ice Data Center. Their latest data is from yesterday, the 25th. This is sea ice concentration in the Arctic. And where you see all the blues, that's where it's melting. And the darker blue it is, the more it's already melted out. And so not very concentrated, meaning it could be thin and space between the pieces of ice, or anyway, it could just be kind of wispy too. So the golden line is the median, so it's pretty far below the median here, and see the blues. So that's in high melt. Now this model doesn't really match with the Navy model, where we saw this circular area, kind of this whole area thinning way down. So we see a little bit coming across here in the blue, a little bit north of the North Pole, and then a lot here in the Beaufort Sea. So that's really in high melt. And here's the sea ice extent, and this is as of yesterday, and we already saw from the Sam Carana post that we're very low for this time of year. We're going to meet up with this 2012 line. It's just barely above the dotted line, which is 2012. The blue line is this year. Here's the Antarctic, and here's the median line. And here's their chart for sea ice extent, again for yesterday. This blue line is this year, the green line is last year, and see, it was kind of running parallel with the green line, and now it's kind of sliding down. So the refreeze is kind of slowing down there. And then Greenland, I'm tracking that. This is as of yesterday on the daily melt. Look at this. That is really not good. And we see the salmon color, see all around these edges, but we see a light salmon color kind of covering the whole ice sheet. It says no melt, but I don't know why. I mean, it looks salmon to me. It looks very pale, but it says no melt. Anyway. I don't know. It should look white, but it doesn't look white to me. Anyway, the darker salmon, see, it's melting on this northern edge and around most of the edges there, and very large melt down here on this southwest edge. Here's the cumulative melt days for this year since January, and so I'm going to assume, here we'll go back, I'm going to assume that what looks like that very pale salmon is actually white. I'm going to assume, but it looks different here. Here it's white. So, whatever. They've got a bleed through there on their model. So, you see the blues anywhere starting with blue and then going into darker blue, and then it'll go through the colors of the rainbow. As it melts more and more. Here's the chart for melt extent. This is as of yesterday. And here's where it had spiked up last week. And then it dropped down, and now it's spiking up again. We're running a little bit below the median right now. That's all of those. Now we'll move on to NASA Worldview, and I'm going to start off in the Antarctic, and here's where it's dark, and I'm going to turn on this nighttime layer. I've been tracking this iceberg A76. I'm just intrigued with this iceberg. It broke off down here off of the edge of the Weddell ice shelf, and we've been watching it come up through the Weddell Sea and wondering if it's going to get frozen in or not. And it's right here. It's kind of hard to see. And there's a cut and paste, but you can make it out right there. But let's go back to last Sunday, and here's where it was last Sunday, and at that point it was not being held in by the ice, and see, it's free of ice on this left side. So I was thinking it would get free before the refreeze caught up with it, but I'm not so sure now. So let's click through and see what it did this week. And over here is the Western Peninsula. So this is the edge of the sea ice right here. where it's refreezing, sorry. So here it was on the 20th. See how that's all open water there on the left, but it does have ice forming, and I'm thinking forming up next to it and kind of holding it in. There's the 21st, 22nd, 23rd, so it's still open on the this left side. 24th. Now that was a big move. Look at this. From the 23rd, see the jump on the 24th. We can't really see it that good on the 25th. And here we can barely make out the shape on the 26th. I'm thinking we're looking through a cloud there. So that's what we've got on our iceberg A76 and tracking its journey. And that's all I wanted to show down there. Now let's refresh. Now we'll look at the Arctic, and we'll turn on our sea ice concentration layer, and we'll turn on the blue marble layer to cut out the clouds. And wherever you see colors, that means it's melting. And so this is today, and we can see this Beaufort Sea is in very high melt, and with the green, usually we can see pretty good size holes in the ice once you see it getting down into the green color. And here in the Lactav Sea and the Kara Sea and so forth. But this is dramatic here in the Beaufort Sea. So let's see what it did this week. We'll go back to the 19th. Here we were last Sunday. So here we go. It was Monday, Tuesday. So see the melting coming in here on Tuesday. And remember, this was the solstice. So the longest day of the year for the northern hemisphere, and the longest night of the year for the southern hemisphere. And then it just reverses starting the next day. Look at this melt here going on. Here's the 23rd, and look how pink everything's getting. So everything is really starting to on its deterioration here. Here's the 24th, 25th. Look at that huge melt going on there. And then today, so it's exponentially melting, you know, just really heating up right there. We also saw a lot more melting here in the Lactav Sea and around this New Siberian Islands region. So let's turn those layers off now. And then we'll look at it just with the satellite view. And let's start here at Greenland. This is a really good view. Look, no clouds. Look at this. It's usually not this clear of a view. So this is the Lincoln Sea here, and it's breaking up into smaller pieces and flowing out here through the nearest strait. This is Ellesmere Island up here, and you can see the ice, and there's open water between those pieces. Here's the nearest strait. Look at all this open water. So it's flowing out pretty good. And here's where it opens out into the Baffin Bay. Here we're into clouds. Let's look at yesterday. That's better. Look here where it's coming out. So see, wherever you see the blue or even the green or brown, that's open water. And then coming down in the Baffin Bay, a lot of this is open water. Here's the 24th. Let's see. Look how this is melting out. See these tributaries, and see it starts breaking up in one place, and see up into the pieces, and then it's flowing though. Let's go up here. Look, there's some holes. Here's some holes. And you can see the change in the color. That's as it's melting, it turns into the bluish green color. See? So let's go back. Here we are today. Now let's go back. Here's the Hudson Bay today. So this ice down here is pretty thin, and this is coming apart fast. You can see. And this Hudson Strait, see, that's open. And then here's where the Atlantic comes up into the Baffin Bay. Here's Greenland. Here's our rainstorm. See the cloud over this southern edge. Let's look at it yesterday. See, it was raining right around this edge yesterday, and it's raining here today. And we did see high melt on this ice sheet yesterday. Here we are today, and this west side of Greenland is pretty open. See? Here's a little ice there. And then here's the ice on the east side of Greenland. And it's in high melt. So the earthquake happened right up here between Svalbard and Greenland, right in the Fram Strait. Yeah, we've got some clouds here, but look at this north edge of Greenland. See the ice? You can see it breaking up here. So this is where some of the thicker ice is, right along the coast of Greenland and along this Canadian coast. And so as the ice melts, this area, it'll be like a line going across. That'll be the last ice that'll be left. Of course, it'll be thinning down, and it'll be flowing out through these tributaries too. Here's Svalbard, it's open. Here's Franz Josef Land, it's open. Here's Novaya Zemlya. Here's the ice on that east side. And we're looking through some clouds here. Here's Yamal Peninsula. Look at this Gulf of Ob. That's open. Let's see. And it's all brown there. That's the sediment. Let's see. Here's the Kara Sea. Here's the ice. See? That's in high melt. A lot of open water there. And this is Severnaya Zemlya. Right down here is Komsomolets. This is the area where we've seen methane billowing a lot. Also here in the North Kara Sea, it's percolating. Now this October Revolution Island, this whole Severnaya Zemlya is made up of ice caps. And look at this. The most famous one, or the one I know about the most, is this Vovolov ice cap. And the ice is flowing into the ocean. And we don't have a real good view of that yet. But as it melts, as the ice melts here in the ocean, we'll be able to see the ice flow coming out from that glacier. See, here's open water. And there's the edge, the eastern edge of the ice. And then coming on up, here's Taimyr Peninsula. A lot of this is open. We're looking through a cloud here. And then here's the Laptev Sea. And look how open that is. We're looking through a cloud. Here's some ice up by the coastline. Here's yesterday. Here's the day before. And then coming on around. So here's Siberia. Okay, now look at this is the East Siberia Sea. Look at this. This is dramatic. This has just started coming apart this week. See that? And then this is open along this bottom edge of New Siberian Islands. See, you can see that's pretty open there. And then coming on around, that's open. And here's the Bering Strait, that's open. See, no ice up here in this Chukchi Sea area. And here's the ice edge. See the melting. And here's the Beaufort Sea. And so this is the area where we saw the high melt going on. So let's turn that back on. Look. Really, this whole Beaufort Sea is just coming apart, like exploding apart. You can't, it's so weird to see the model and then, okay, we're looking through a cloud. Trying to see it. Let's see. So let's go back up here. Here's yesterday. Here's the day before. And then coming down, and we're back to Canada. Now let's see if we can see what Sam Carana was looking at. So here's the North Pole. Look down here. There's the sea ice. See, it's breaking up. Look. Look, you can see the ice almost up to the North Pole. And see, it's breaking up in between the pieces. You can see open water almost. Look at this. And then Greenland's right down here. And see here. This is just east of the North Pole. See. See. And here. See. Now there was a spot just north of the North Pole where it was opening up. Let's see. It's not visible today. Let's go back. So here it was on the 24th. I can't really tell because we're looking through clouds here. But here's the ice up here. This is at 88 degrees north latitude. And the North Pole is at 90. So let's go back to today. here. See? There's quite a bit of open water there. Up here. So it's really breaking up quite a bit. Look at this. And this is at 86. And here. See the dark? That's the open water. And like I said, even if it's just a little tiny bit of open water, that's an area where the heat from the sun, the radiation from the sun, is absorbing instead of being reflected back. And this is 80 degrees north latitude there. So that's about all we can see right now. So it's in high melt. Now, let's just take a peek at earthquakes. Right now there are 245 worldwide, and this area in the South Atlantic, not too far from this western peninsula, 5.3 and 4.9 South Sandwich Islands. And we're seeing a lot of 4s, not too many 5s, but a lot of 4s, see, on all these red lines. And let's turn on 7 days, all magnitudes. So this week we had 2,204 earthquakes. Here's that one up next to Svalbard that came in last night, 4.3. There was one on Iceland, 4.5 on the 23rd. And see a lot of movement on this Atlantic plate coming all the way down. And well, on all the red lines. So let's look at 4.5 magnitude and higher. So the U.S., everything was under 4.5 magnitude in the U.S. this week. And don't remember if we had any 6s. I don't see any 6s. We had a couple of 5s, or a few 5s, and the rest were 4s. A couple of places were swarming this week. Here in the Persian Gulf and Iran, this was going off. 5.3, 4.9, and 5.6. Now let's turn on our all magnitudes. See, 8 here. So these were lower 4s too. So that was a little cluster there in the Persian Gulf. Also, here in the US, I wanted to show Mammoth Lakes was very active. This is here in California, and it's the Long Valley Caldera supervolcano region, and 275 earthquakes here this week. And see, it was forming mainly up here in the Mammoth Lakes area, but see the movement spread out too. And the largest ones, largest was a 3.0, so they weren't big, but there were a lot of them, and most of them were at this negative depth. Like here's this 3.0 at a negative 0.1 kilometer depth on the 20th. And what that means is that magma is rising up in the chamber and is causing the earthquake up in the mountain. See, all of these are negative depths, and we've got a couple up here that are not negative depths. So that's something to keep an eye on. That caught my attention the most this week. We had only one on the Juan de Fuca plate at 2.9, and so on. So that's my report for tonight. And now, I always like to bring my shows back to a spiritual perspective, because, you know, when you're talking about the end of life, and potentially all life, and it was prophesied in the Bible that this would happen, I think we need to bring it to a spiritual perspective. And I'll continue reading out of the Book of Wisdom. This is one of the Apocrypha books, and this was written by Solomon. Wisdom chapter 7. I myself also am a mortal man, like to all, and the offspring of him that was first made of the earth. And in my mother's womb was fashioned to be flesh in the time of 10 months, being compacted in blood of the seed of man, and the pleasure that came with sleep. And when I was born, I drew in the common air, and fell upon the earth, which is of like nature, and the first voice which I uttered was crying, as all others do. I was nursed in swaddling clothes, and that with cares, for there is no king that had any other beginning of birth. For all men have one entrance into life, and the light going out. Wherefore I prayed, and understanding was given me. I called upon God, and the spirit of wisdom came to me. I preferred her before scepters and thrones, and esteemed riches nothing in comparison of her. Neither compared I unto her any precious stone, because all gold in respect of her is as a little sand, and silver shall be counted as clay before her. I loved her above health and beauty, and chose to have her instead of light, for the light that cometh from her never goeth out. All good things together came to me with her, and innumerable riches in her hands, and I rejoiced in them all, because wisdom goeth before them, and I knew not that she was the mother of them. I learned diligently, and do communicate her liberally. I do not hide her riches. For she is a treasure unto men that never faileth, which they that use become the friends of God, being commended for the gifts that come from learning. God hath granted me to speak as I would, and to conceive as is meet for the things that are given me, because it is he that leadeth unto wisdom and directeth the wise. For in his hand are both we and our words, all wisdom also, and knowledge of workmanship. For he hath given me certain knowledge of the things that are, namely, to know how the world was made, and the operation of the elements, and beginning, ending, and midst of the times, the alterations of the turning of the sun, and the change of seasons, the circuits of years, and the positions of stars, the natures of living creatures, and the furies of wild beasts, the violence of winds, and the reasonings of men, the diversities of plants, and the virtues of roots, and all such things as are either secret or manifest, them I know. For wisdom, which is the worker of all things, taught me, for in her is an understanding spirit holy, one only, manifold, subtle, lively, clear, undefiled, plain, not subject to hurt, loving the thing that is good quick, which cannot be letted, ready to do good, kind to man, steadfast, sure, free from care, having all power, overseeing all things, and going through all understanding, pure and most subtle spirits. For wisdom is more moving than any motion. She passeth and goeth through all things by reason of her pureness, for she is the breath of the power of God, and a pure influence flowing from the glory of the Almighty. Therefore can no defiled thing fall into her. For she is the brightness of the everlasting light, the unspotted mirror of the power of God, and the image of his goodness. And being but one, she can do all things, and remaining in herself, she maketh all things new, and in all ages entering into holy souls, she maketh them friends of God and prophets. For God loveth none but him that dwelleth with wisdom. For she is more beautiful than the sun, and above all the order of stars, being compared with the light, she is found before it. For after this cometh night, but vice shall not prevail against wisdom. Wisdom chapter 7. I just think that's a beautiful, beautiful chapter. The way he wrote that, he had so much wisdom. Obviously, I mean, that's what God bestowed upon him. And if we pray for wisdom, God will bestow it on us. And we need wisdom. We really need wisdom in these end days. We need discernment, and we need the protection and the guidance that can only be had from God and Jesus. If you haven't given your life to Jesus Christ, I highly recommend it. It's not too late. It's not too late yet. So I hope everyone has as good a week as possible. I love you all, and I'm praying for you. And until next time, God bless you. Go in peace, and I will talk to you soon. Good night.